Guys, appreciate it. Okay, so welcome to today's webinar. We're going to discuss pattern recognition for GCP exams, mainly focused on the terms and the words that you should be paying attention to as you are taking GCP exams and practice exams in order to be able to speed up the amount of time that it takes you to answer a question and also increase the probability that you will be selecting the right answer in the process. So, a couple of notes before we start, just to kind of set the groundwork and expectations for this presentation. So, a lot of GCP exam questions require more detailed knowledge than the information that I'm going to talk about today, right? I want to set this expectation up front. The point in this presentation is that many questions can be answered or significantly narrowed down by simply knowing which services are definitely candidates and which services are definitely not candidates. So my goal is to give you kind of a framework or heuristics or sort of rules of thumb or patterns to watch out for that can make things easier. This is kind of following this Pareto principle of, looking at the 20% of information that will kind of get you 80% of the way there to answering these questions. Not all of, the questions on GCP exams just require you to pick a service. Sometimes it's a specific detail or feature about that GCP service. And so we're going to mainly be talking about which services are kind of in play based on the words that are being used in the business or technical requirements in the question. But that will, get you most of the way there. There may be extra details, that you need to think about or know in order to get 100% of the way there. But for the sake of this webinar, to kind of get the most out of the time that we're spending together, I spent time putting together this kind of list or way of thinking about the questions so that you guys can, at least narrow things down significantly. So it's not comprehensive, and we're going to be focused on the patterns that tend to show up often and across multiple GCP certifications, right? So obviously the services and the features that are included in each exam is different. The services on the professional ML engineer exam are different from are a little bit different from those are on the PCA exam, which are different from those on the data engineering exam and the ACE exam. So there could be a presentation like this or even longer than this for each of those certifications, but I'm going to go through the patterns that kind of tend to show up across all of them. Okay, so first I'm going to talk about the most important meta pattern that you should memorize and get drilled into your brain. If there's one kind of rule that I would suggest someone think about or digest in order to most effectively guide their answering of Google questions on GCP exams, it would be the one in this section. And that is thinking about management levels in GCP. Okay, so what are management levels in GCP? A lot of you might have heard of these terms before. A lot of you might be already be familiar with this, but basically, services on GCP can be thought of as either being unmanaged, managed, or serverless. They kind of fall on the spectrum defined by the amount that the service or the tool is managed by Google, right? So the question is, do you manage the infrastructure or does Google? Do you manage the operating system or does Google? Are there still infrastructure settings that you have to configure? Or does Google handle all that for you? Do you handle the scaling, or does Google handle that automatically? The more that those things are automated and handled by Google, the closer to the right-hand side of this slide that service would be, right? So if you don't have to worry about scaling, if you don't have to worry about updates to the operating system, if you don't have to worry about the infrastructure, then Google is basically taking on all of the operational responsibility for that service. So that is this spectrum. And what I'm going to suggest that you guys do, and I'm going to kind of allow you to do in this presentation, is get inside Google's head when we're talking about GCP exams. So, in general, Google wants to promote their fully managed and serverless services, right? So, kind of the whole point of cloud, if you think about it, is to take the burden off of the customer, the company, or the person using Google Cloud, and put that on Google. And then you pay for an extra, abstraction of the service so that you don't have to deal with the operating system, patches, scaling, all that stuff that you would have to deal with if you were running your own on-prem, data center. And so our first kind of category of words and phrases that I want you to pay attention to relate to this spectrum, right? So on the left here, we've got terms that might show up in a question indicating that you want to take an unmanaged approach. Something describing a custom solution, something describing that the company wants to keep things on-prem, something describing that they want to maintain their legacy applications, maybe migrate later, describing kind of a lift and shift. Maybe that's moving things to compute engine, which is still an unmanaged service. That would mean that the solution is unmanaged, and you should think about the tools or services or approaches that would keep the solution unmanaged, right? And then on the right-hand side, we have some words that Google would use in questions where it's really trying to push a no-ops or serverless or fully managed approach to the scenario. So, Google would probably tout that if you use their serverless or no-ops services or approaches, then you would be lowering your cost. There are some people who would debate that depending on the solution or the scenario. But they would pretty much, Google would pretty much tout that moving toward management and serverless services would lower your cost. If there's no operational overhead, that would point towards serverless. If they literally use the word serverless, I mean, sometimes that shows up in the question, that would point towards serverless. And then, these terms managed or fully managed would indicate that as well. So this can, I mean, there are probably like 30 to 50% of questions on GCP exams relate to this spectrum and this distinction in some way, right? You'll see like 4 or 5 answer choices, and some of them will be unmanaged or less managed, and others will be more managed, or they will be serverless or no ops. And Google basically, their whole point in having GCP is to kind of push you toward these managed services, and they kind of tout and trumpet the benefits of moving toward managed services. So that is one thing that will significantly help you if you keep that in mind. So just to get a little bit more specific about the services that would fall into kind of each of these categories, right? So on the left, we have unmanaged. That would include on-prem infrastructure. I mean, if you have your own data center, your own servers that you are managing, that you have an IT team that is managing, that would be unmanaged. And then compute engine as well, unless you are using a managed instance group, which is an extra kind of layer of abstraction on top of compute engine. Compute engine would count as infrastructure as a service. It would count as an unmanaged solution. And then in the middle, we have kind of managed, not necessarily fully managed, but managed services. We've got App Engine, App Engine is kind of like, it's debatable. It's in this middle ground. It depends on whether you're using App Engine Flexible or App Engine Standard, but I put it in this middle ground. We've got, Bigtable. You do still have to configure some of the infrastructure with Bigtable. Dataproc, similarly, although there's Dataproc serverless now, which can kind of make it serverless. There's Kubernetes engine. So that's kind of in the middle category of managed, but not necessarily serverless. And then on the right, we have some examples of serverless and no ops, right? So PubSub, which is a fully managed version of Apache Kafka, Dataflow, which is the same for Apache Beam. We've got BigQuery, we've got Cloud Functions, which are now called Cloud Run Functions, although the icon hasn't been updated. And then we've got Cloud Run. And then Vertex AI I have here as well. Vertex AI is like a platform, right, with almost like many different services within it, focused on machine learning and AI. So some aspects of it are managed, like fully managed, like Vertex AI endpoints, for example. But then there are other aspects that are not fully managed, like custom training, right? And so, or custom containers. And so, like depending on which aspect of Vertex AI you're using, you might you might count it as serverless or fully managed or not. But in general, this is kind of the spectrum that you want to pay attention to. Think about, okay, when I'm learning a service, does it count as managed? Does it count as serverless? How much of the actual operation of the service itself am I responsible for if I'm using it on GCP? Right. And that will really help you as you're answering exam questions. Okay. I spent a little bit more time on this section than I intended to. We're going to kind of keep it rolling. And the next section is going to kind of cover, so we're going to go from kind of more general and meta to like more specific, right? So the previous section was this like overarching kind of principle that you want to keep in mind as you are preparing for your GCP exams, and taking, and answering exam questions. This is like the most important services that will show up on GCP exams, and the words in questions that will very strongly indicate, not guarantee, but very strongly indicate that service could be the solution, or at least part of the solution, right? I actually initially had this as the Big 10 because that sounded nice, but then I changed the list and now it's 9, and I didn't want to add one just for the sake of making it 10. So it's the Big 9. This is the list of the 9 most important services to keep in mind for GCP exams, and the words that would in questions that would indicate them. Okay, so probably not surprising to a lot of you guys, but BigQuery. You should think BigQuery if you see analytics, if you see SQL, if you see relational, if you see a solution that is on the order of petabytes of data. If the question mentions ad hoc queries, if the question mentions data warehouse as a solution, BigQuery is just kind of known as the data warehouse service in GCP. These things point very strongly toward BigQuery. Honestly, these obviously vary in how specific they are. There are multiple services that could go along with the word analytics, but if you see 2 or 3 of these in a question, you should very strongly consider BigQuery. We're going to just kind of keep it moving here because it's 2:20 already, and I want to leave some time for questions and get through everything. So kind of similarly, Bigtable, it's often accompanied by a question that mentions Internet of Things, or fleets of devices or sensors that are sending data to the cloud. Time series, it's really good at those use cases. High throughput analytics. Actually, one common confusion with Bigtable is how is it a NoSQL database, but it's good for analytics, and essentially it's just really good at reads and writes. Like, it's just really good at high throughput use cases and high volume use cases. And so, especially with tables that kind of look like time series use cases, it's really good at analytics on those kinds of tables, right? But if you're doing complex querying, if you're doing ad hoc queries, Bigtable is not the best for that, especially if your data is NoSQL. Similar to kind of high throughput analytics, although throughput and latency are not exactly related. High throughput does not necessarily mean the exact same thing as low latency. they often kind of go together. And so, low latency in a question with one of these other uh, terms is very likely to indicate cloud big table as well. So that is number two. Keeping it moving, we're going to look at data flow. So data flow, again, it's a serverless service. GCP loves to promote data flow, especially as like a great solution in the era of big data. So if you see streaming, if you see real time, if you see batch and streaming, especially, if you see Apache Beam or migrating Apache Beam, if you see a pipeline mentioned or transformations mentioned, think data flow. Again, these terms individually could be used with another service, right? Pipeline could be with, Cloud Composer. Um, it could be, with cloud workflows, depending. It could be with cloud functions, depending. Transformations, kind of similar, with data form, right? But especially if you have two or more of these terms together or synonyms of these terms, you should think data flow, right? Apache Beam with pipeline, Apache Beam with transformations, streaming and real time. I mean, those are kind of synonymous, but like streaming and transformations, or real time pipeline, right? You kind of get the idea. Those things in combination significantly narrow it down and point to a service like data flow. Okay. All right. Now, kind of in a similar vein, data proc. So data proc is the managed version of GCP's managed version of Apache Spark. So if you see a Hadoop environment mentioned, or migrating a Hadoop workload to GCP, if you see migrating a Spark workload to GCP, or using Spark on GCP, if you see HDFS mentioned, which is the storage system that goes along with those jobs, usually that is hosted on Dataproc. A lot of times the use cases that mention Dataproc include existing workloads. So Google kind of is encouraging people to use data flow if they're building from scratch, because data flow is just like, it does both batch and streaming, and it's more of a managed service. It is more serverless than Dataproc is. So a lot of the times when Dataproc is the answer, the use case involves an existing workload, like a migration, where the team is familiar with Hadoop or Spark. So, I have that here kind of under the phrase of existing code. And then also Dataproc, as I mentioned a few slides ago, is managed but not serverless. So if the question mentions serverless, and Dataproc serverless specifically is not one of the answers, then you probably want to consider another service. But if it mentions that it wants a full a managed service, then you could consider Dataproc, especially in combination with one of these other terms. Okay. My throat's getting a little dry. Let me take a sip of water. Okay. All right. Keeping it moving. Now we've got Cloud Composer. So with Cloud Composer, you really want to think of things like orchestrating workflows or orchestrating pipelines. If a DAG or directed acyclic graph is mentioned, think of Cloud Composer. It is the managed version of Apache Airflow. So if Airflow is mentioned, definitely think of Cloud Composer. A lot of the times, the jobs that will be put in Composer have lots of dependencies, and you kind of only want your next stage of the pipeline to execute if the previous stage is successful. I mean, obviously, you kind of always want that, but Cloud Composer allows you to very easily and very clearly articulate that in directed acyclic graphs, those dependencies, and visualize it, And so if dependencies are mentioned in the question, that's kind of a clue that it's Cloud Composer. Again, workflow, uh, like orchestrating workflows, especially indicates Cloud Composer. We're running things on a schedule. Again, not to beat a dead horse or sound like a broken record, but clearly, like schedule could be used with other services. I mean, Cloud Scheduler is literally another service. But if you have schedule, running things on a schedule with another one of these things, that could indicate Cloud Composer. All right. So this isn't really like a service, but it is a general solution that shows up in kind of multiple services because a lot of services use compute engine VMs underneath the hood. So if you see something like a workload being a batch workload, or it being fault tolerant, or cost being a concern, or the workload being interruptible, and it can be restarted, this indicates very strongly the use of preemptible or spot VMs. And these are VMs that are much cheaper, but they are able to be reclaimed by Google for other workloads at any time, right? So Google has all these VMs in their data centers, and you are basically renting those VMs. And if you need to save on costs, you can do so by choosing preemptible or spot VMs instead of standard VMs, and you will save a lot. But the trade off is Google gets to say, hey, we actually need this in order to help out this other customer with their workload. So we're going to shut it down in the next 30 seconds and, make sure that your workload is interruptible and everything's saved, so that you can restart it again when the VM becomes available. So that's the trade-off. It's actually a pretty common thing to show up on exams with multiple different GCP services. So I kind of put this as a category, even though it's not technically its own service. We're going to move on. So we're going to talk about VPC service controls here. And this is, again, like a specific feature of a service, but Google really likes to put this on exams. I think I've seen it on multiple, like actually all of the exams that I have courses up for, except the foundational ones, like generative AI leader or cloud digital leader. All the other ones have a question about this. Like they all have this in scope. So essentially, VPC service controls are relevant if you want to prevent data exfiltration, if a service perimeter is mentioned in the question, if you want to isolate your environment, if a boundary is mentioned in the question, if the question mentions data cannot leave your environment, that significantly points toward VPC service controls. It's a way to add that at the network layer, a a uh, uh, a layer of security to prevent the data from actually like leaving your environment. And there are kind of multiple ways to enforce that. This is just one option, but it's a very convenient thing, and so Google has has been putting it more and more in their exams. I was surprised when I saw this in the data engineer exam originally, because I would think of this as a networking thing, but it's like something that Google is basically saying, well, people in multiple roles need to think about this kind of thing. All right. So for Cloud Run, this is bread and butter GCP serverless services, right? So this is if containers are mentioned, if serverless is mentioned. I mean, honestly, a lot of the times, Cloud Run will be the answer in questions where literally the question says that the solution needs to be serverless. Stateless containers specifically, HTTP requests, variable traffic, needing the service to be able to scale to zero. These things all point toward Cloud Run, and so this is something that's definitely good to know. And again, this is showing up actually not just in not just in like the cloud developer exam or the cloud architect exam, but even in the data engineer, exam, because Cloud Run is becoming more and more popular, more and more something that GCP is pushing. It's actually like one of the reasons that people move from AWS or Azure to GCP, because Cloud Run is such a great service. And so if you see any of these terms, definitely think of Cloud Run. And then cloud storage, this is pretty straightforward, but if you see, oh, sorry, a few of these cards snuck in from the last slide. Unstructured data, or objects that you need to store, or if you're doing like a backup or an archive, definitely think of cloud storage. It's just like it can store any kind of data, that you don't need like a specialized database for. Okay, now we're going to talk about patterns by solution category. So this is not necessarily like focused on a specific service, but like I'm going to talk about basically the different categories of solutions like networking or IAM or monitoring, and what the most common patterns are. And they might include services that are similar to each other. They might include services that are not. And so this is going to be kind of a rapid fire thing. Again, we're getting from more general to more specific. And I think I have about like 7 or 8 slides in this section, and then we'll see where we're at and open it up to questions before we close out. Okay. So top data transfer patterns. So if you see situations mentioning cloud to cloud transfers, S3 buckets being the source, high bandwidth, meaning that you can rely on the internet to carry the data, especially if it's from on-prem. If you're doing a scheduled transfer, think of storage transfer service. If you're doing an absolutely massive transfer, think of transfer appliance. Or if it mentions wanting to actually put the data on something physical, that's when you want to use the transfer appliance and order that and put all your data on that appliance and then ship it back to Google. If you see change data capture or replication, database replication, or capturing database changes or real-time sync, think of data stream. That's something that Google is touting more and more in the last few years. If you're thinking, if you see in the question SAS to BigQuery, if you think of Redshift as a source, Teradata as a source, or an S3 bucket specifically with relational data, which indicates that it's probably going to BigQuery or another relational database. Think of BigQuery data transfer service. So these are the data transfer patterns that I would suggest. Again, not comprehensive, but they're the quick hits. Top networking patterns. All right, so if you see on-prem, high bandwidth, low latency, private connection, or fast like needing a fast connection, think of dedicated interconnect. There are multiple types of interconnect under cloud interconnect, the service, but dedicated interconnect is the one that's most likely to be pushed as the answer to a question. Not saying the other ones couldn't, but dedicated interconnect is the most common that shows up in use cases on GCP exams. Multi-zone use cases, multi-region use cases, high availability, or surviving a failure. Think about a solution that deploys across zones or uses a load balancer. This would typically be with Compute Engine or Kubernetes Engine that we're talking about here. Controlling your traffic. If you see an example question, a question that talks about controlling traffic between tiers of VMs or tiers of an application, or segmenting your network, or allowing and denying traffic to different parts of an application. Think of using network tags and firewall rules. You can actually base firewall rules on network tags, which is something that Google likes to put forward as like a convenient solution in networking. If you've got a question that mentions private subnets or outbound internet, or external IP addresses not being allowed, or wanting to kind of download updates, in one of these scenarios, Cloud NAT or network address translation is useful. And it's something that's kind of being pushed more and more and it often accompanies these scenarios where you don't allow your VMs to have external IP addresses. Cloud NAT would take care of those outbound requests. All right. So Cloud Run, a mention of serverless or accessing VPC resources or connecting to a private database. This often entails using direct VPC egress or VPC connector. Direct VPC egress is the newer solution, but VPC connector is it also works. It's just they're unlikely to actually show up side by side in a question, but if you see one or the other, that's probably the answer in this kind of scenario. If you see a situation where multiple projects are mentioned, or a shared network, or having kind of one central area to administer the network, or if you have separate teams, but you want one network, use shared VPC or strongly consider shared VPC. All right, moving on. Okay, top identity and access management patterns. This might be a bit of a review for some of you, but these are really good rules of thumb. So, you should basically always follow the principle of least privilege, and those that will be the solution to questions where minimum access or giving someone only what's needed is mentioned in the question. If you have a question mentioning multiple users or giving them the same access or team permissions, you should consider Google Groups or assigning a role to a group if the group already exists. If the question mentions cross-project permissions or accessing a resource in another project, it's probably testing whether you know that the role should be assigned in the target resource, not the source resource, which feels self-explanatory, but you'd be surprised how many people mix that up. And then rules of thumb, if the question mentions view only or read only or cannot modify, think of viewer roles. These can be predefined service specific roles, not necessarily project-wide roles. And then similarly for the next two lines here, if they have to read and write, if they have to modify the resource but not necessarily have complete control over it, think of editor roles. But then, of course, if they need full control, or if they need to manage the permissions themselves, then you should think of predefined admin roles or project level or org level owner roles. Okay. All right, moving on. Again, my throat is getting a little bit dry. Sorry about this. I don't want to be like coughing in the mic. Okay, monitoring and operations. So, if the question mentions you want to see metrics or custom metrics and put that somewhere, or error rates, or look at a performance dashboard, you should look at cloud monitoring. If you want to diagnose errors, if you want to see who did what, if you need an audit trail, if you need to debug something, if you want to look at application logs, you should look at cloud logging for the most part. If a question mentions a microservices scenario where you need to measure latency, you need to trace requests, you need to look at things end to end, or there's some kind of bottleneck that you need to diagnose. Cloud Trace is often the solution. If a question mentions compute engine specifically, memory, metrics, which are not, included by default, or disk metrics or OS level logs, you should consider adding the ops agent to your compute engine VM. I think this is also something in Kubernetes engine, if I'm not mistaken. It's like an extra setting that you enable, and then those extra logs will be sent to cloud logging. And then if oh, again, that snuck in from the previous slide. Sorry about that. The last line is the only one left that we have to review here. So long-term retention on logs, and the archiving logs, and then the last part is compliance. Yeah, and keeping logs beyond 30 days. Sorry, the last line was obstructed by this note on the actual live stream. That That points to a solution where you would be exporting logs to cloud storage specifically. So you're not just looking at cloud logging as the solution, but actually exporting those logs to cloud storage so that you can keep them, or so that you can, yeah, give them to an auditor or keep them for a certain number of years for compliance reasons. Okay, different approaches to compute selection based on patterns. So again, we went over Cloud Run. I'm not going to go through that again, actually, but Cloud Run functions. Again, this is the new name for Cloud Functions. We've got serverless. It is also a serverless service, specifically for event-driven workloads, short tasks. There's actually like a time limit to how long Cloud Run functions can run for. If the question mentions lightweight, that is the term that often Google uses to refer to these workloads that Cloud Run functions take on, or something being triggered upon upload. That points toward Cloud Run functions. Containers, orchestration, complex, multiple services, or Kubernetes, that would probably point toward GKE. And then just because Compute Engine is infrastructure as a service, like you get access to different types of VMs, and it's like the bare metal service or offering, then any of these really point toward Compute Engine. So if you need full control over the VM, if you need to put custom software, and not just use the software that is available through one of the other services. If you need a specific operating system, adding GPUs, not necessarily in Vertex AI. If you want to bring your own license, if you're bringing legacy applications to the cloud, doing lift and shift, and you don't want to change any of the code or adapt it for another service, migrating it as it is, think of Compute Engine. I hope that makes sense. Okay, more database selection patterns. So I'm not going to go over the ones that were already in kind of the first couple sections. We went over BigQuery and Bigtable there. Otherwise, those would be in this list. Cloud SQL, you should think of Cloud SQL if relational is mentioned. If SQL is mentioned, I mean, it shares that with BigQuery, right? But it's for very different workloads. It's a transactional database, not an analytics database. And if it mentions single region, if it mentions PostgreSQL, if it mentions MySQL, if it mentions managed, Cloud SQL is a managed service, then then you should consider Cloud SQL. But it's for these like smaller workloads as well. That could have been another word that's added in that list, although it doesn't necessarily. They wouldn't necessarily use the word smaller, but like anything on the order of like tens of terabytes or less could go in there. I think the limit beyond like 60 terabytes or something. It would need to go to BigQuery or another database. Cloud Spanner is also a relational database. If the solution of the question mentions needing to be global, especially globally available, horizontal scaling with strong consistency, and multi-region. They might use multi-region instead of global. Think of Spanner. If the use case mentions NoSQL, documents, hierarchical data, especially mobile or web apps or user profiles, think of Firestore. Firestore is the database that historically, has been made available through kind of the Firebase console, where a lot of teams and startups will build out their like mobile apps or web apps. Now it is mostly available as its own actual like database within GCP, because there's so much like crossover between GCP and Firebase and Firestore. So now if you look in the console, it's its own service. And then memory store is another thing. So if it literally says in memory or caching or Redis or Memcached, which are kind of the two types of databases that are available within memory store, or sub-millisecond reads, then you should think of memory store. And then we've got AlloyDB, which is something that has been pushed more recently. It's kind of it's basically PostgreSQL on steroids, right? So there are these workloads that kind of weren't compatible with Cloud SQL, that people using PostgreSQL weren't able to use Cloud SQL for. And so they needed more performance, and Google has provided AlloDB as kind of this beefed up high performance, either transactional or analytical workload database. I haven't used it myself, honestly, but it's come up on exams more recently. More top data engineering selection patterns. So, we mentioned Dataflow, Dataproc, BigQuery, Cloud Composer. These are some more. So PubSub should be for scenarios where messaging is mentioned, decoupling is mentioned, making things asynchronous is mentioned, or event driven, or at least once delivery, or the word queue is mentioned, like a queue of messages. That strongly indicates PubSub. If you've got no code or GUI or ETL, actually ELT could also be something for data fusion. Again, pipelines, not just appropriate for data flow, but also for data fusion. It's got a lot of different data sources, including from other clouds, so hybrid cloud. And then it's got this drag and drop visual designer, in it, which is convenient. So that points toward data fusion. Data prep is, again, a no-code solution, so that points toward either data fusion or data prep. But data prep is specifically for data cleaning and wrangling, and it's for these kinds of like analysts or even like business people who are a little bit technical, and they want a way to clean or prepare the data. That points toward data prep. Dataplex should be considered when governance is mentioned, data lineage is mentioned, a data catalog is mentioned, data quality is mentioned, or like discovering data is mentioned. Dataplex is actually basically like swallowing up and replacing data catalog. So if you notice, there's some overlap between what data catalog historically has done and what Dataplex can do. And then we've got Analytics Hub. So Analytics Hub is a way to share data, especially with third parties, giving them external access, and governing that sharing. So, if you see those terms mentioned, then you should consider Analytics Hub. Okay. Top AI and ML patterns. So if you see pipeline automating the lifecycle of ML, orchestrate training, that probably indicates Vertex AI pipelines. If you're talking about deploying a model, if it literally says endpoint or online prediction or decoupling prediction from an application of yours, that could indicate Vertex AI endpoints. If you see a question mentioning custom pre-processing or bringing your own model, that could indicate using a custom container on Vertex AI. These are the common things that come up with AI or ML questions, especially in the professional ML engineer exam, but also in a couple of others. There may be one or two questions on this stuff. Experiment tracking, comparing runs, looking at hyperparameters, those often indicate Vertex AI experiments, although not universally. Something like drift detection or data skew is mentioned, then model monitoring is probably in play. And it is, again, you can do model monitoring on your own, but it is the managed solution to monitoring that Google is touting. And then experimenting with multiple models or comparing outputs, especially for LLMs specifically, Google AI Studio is the place where you typically do that, although there is Vertex AI Studio as well. All right, top governance and security patterns. And then I think this is the last slide before we go to questions. We're over time a little bit, but good to see folks are sticking around. So if you see enforcing org-wide rules, restricting locations, if you see policy compliance mentioned, if you see, disallowing IP addresses, this would indicate using org policies. The two org policies that are most commonly tested on the exam are only allowing certain resource locations, so like certain regions around the world within GCP. And then the other one is disallowing external IP addresses with VMs. Those are by far the most commonly tested. So, and those there are many org policies, but from a security and governance perspective, those are the most common to show up on exams. Yeah, data lineage. This was in a different slide, but it actually is this time. It's not a mistake. It does also go in governance because this is data governance. So if you see data lineage or discovering data or data quality or data catalog, you should think Dataplex again. Dataplex um, is growing as a service in terms of its features, and so it again is swallowing up the capabilities of data catalog, but it's also fulfilling this kind of ability to allow organizations to create data meshes and also govern their data more easily as well. And then we've got DLP, Cloud DLP, which is now part of sensitive data protection. As you guys know, Google loves to just like rename their services. And I'm not sure exactly what the difference is between them right now, but they could show up. It could show up under either of these terms, data loss protection or sensitive data protection. I think that DLP is basically like the API underneath the broader service of sensitive data protection. And so if you see PII, if you see detect sensitive data, if you see masking data or de-identifying data, that often points toward Cloud DLP. But again, like the DLP, there are probably more specifics that you would need to know in regards to the type of masking. There are different types of masking that's included in my course. And so it's not necessarily enough to just know DLP, although that for some questions it might be. But you get to narrow it down to maybe like two options just by knowing that the DLP or sensitive data protection is what goes along with those kinds of terms in the question. And then verifying container images or making sure your deployments are trusted or achieving attestation. This usually points toward binary authorization, which is a technique. It is not a service, and that often comes up in Kubernetes engine use cases or Cloud Run use cases as well. Basically, actually anywhere that you're using a container registry or actually artifact registry now. All right, that was a lot. I hope this was helpful. Feel free to reach out with any questions. I'll stick around a little bit to take some questions now, if you guys have any, and this will be posted on the community, the Circle community, for folks to access. And this is free, so some of you I think have a paid subscription, which I appreciate. Others of you are popping in and kind of curious, to get some help when you're studying for your exam, or just kind of meet me and see, how I communicate. And I'm really appreciative, regardless, that you all are here. And yeah, I'm not going to sell you on my course. I hope this was helpful, regardless. But this is, this just kind of goes to show that like these are patterns that I've noticed, and that I'm kind of able to notice because of just how many people I have helped pass their Google Cloud exams. Right? These are thousands of students and thousands of questions, and these are the kinds of things that come up. So it's not everything, it's not comprehensive, but this will get you like halfway, or maybe a little bit, maybe more than halfway there for a lot of questions. And I think if you go over the recording, take notes, and kind of drill these rules or heuristics into your head, it'll really help you on test day. All right. Yeah, I'll stick around. I don't know if there's a way to like put people on, on mic in order to ask questions, but I'll stick around if folks want to. Thank you for joining. Thank you, guys. Thanks, Mark. Thanks, Jamie.